Binomial expressions. In this lesson, we will learn to find the product of binomial expression such as ax plus by times cx plus dy. So bi means two. So as you see, there are two terms in each part. And then verify product of binomial expressions by means of area of a rectangle or a square. And find square of a binomial expression such as x plus by squared. You might replace your memory that about this binomial expressions and also verify binomial expression by substituting values. Now let's look at the prerequisites that we need to know. Distribution property of multiplication over addition. So we're going to find a times b plus c. So we know we have to multiply everything in second parenthesis by a. So we get a times b plus a times c. Now we can think this one as the area of a rectangle, where area of rectangle is given by length times the breadth or width. So this one we can think about as a length, and this one we as a breadth. So here's a picture what we see here. So we can think about a rectangle of length a and the breadth b plus c. Now what you see here is the area of the big rectangle is equal to the area of two small rectangles. So area of the blue rectangle here is length is a, breadth is b, so that is a times b. That's what we have over here. Area of a second rectangle is a times c, so that's what we have here. Also we need to know the a plus b squared is equal to a squared plus 2ab plus b squared. A squared plus twice ab plus b squared. Now we can see how we got that one. So a squared means you're multiplying something with itself. A plus b times a plus b. That means we are going to multiply the second parenthesis first by a and then by plus b. So you get a times a plus b times a plus b. Now we use the distributive property that the last one we learned. A times a, which is a squared, a times b, which is ab, plus b times a, which is ba, plus b times b, which is b squared. Now these two, ab and b, are the same, so you get 2ab. That's what we get, a squared plus 2ab plus b squared, this formula. Now this one also we think about the area of a square, because a plus b squared mean a plus b times a plus b. They are the length and width are the same, so we can think this is a and this is b and this is a and this is b. Now so we have this blue part, a times a, which is a square, and this part a times b, because this length is a times b, and this part is b times, because this length is a, we get a ba, and this part the length is b and the width is, this is b and this is also b, so we get a b squared. So that's what we get, this formula, a squared plus 2ab, the sum of these two, 2ab plus the b squared. Also we want to know a minus b squared, and we can show a minus b squared, if you can remember, is equal to a squared minus 2ab plus b squared. Now we can show this in two different ways. The one is just use squared mean a minus b multiplied by itself. Now That means first we have to multiply the second parenthesis first by a and then by negative b. So we get a times a minus b minus b times a minus b. So now if I use a distributive law, a times a, we get a squared, a times negative b, which is negative ab. Negative b times a is negative ba, negative b times negative b, which is plus b squared. Now I can combine these two. ab and b are the same, they're both negative, so I get a squared minus 2ab plus b squared, this result. Also, we may be able to use our earlier result where we know a plus b squared is equal to a squared plus 2ab plus b squared. Over here, we could replace b by negative b. If I do that, I get a minus b squared. Now, b has to be replaced by negative b, and so I'll get a squared 2 times a times negative b, that will be negative 2ab, and b is by negative b, so negative b squared is same as b squared, that gives the same result. Also, we need to know the product of a plus b times a minus b. Now we will get this is equal to a squared minus b squared. So we have to multiply the second parenthesis first by a times a minus b plus then by b plus b, and then use the distributive law. A times a is a squared, a times negative b is negative a plus b times a, which is ba, b times negative b is negative b squared. Now negative ab and ba, they are the same opposite side, so that cancel out. That's what we get, this result. Let's put the prerequisite to some small problem. Suppose we want to find x plus 3 squared. Now we should recognize this as a plus b squared. This looks like a plus b squared. Now we use that, you get a squared, which is x squared here, plus 2 times a times b, which is 2 times x times 3, which is 6x, plus b squared, which is 9. Suppose we want to find x minus 5 squared. So we should recognize this as a minus b squared, a minus b squared. So if we have a minus b squared, we have a squared minus 2ab plus b squared. Therefore, we'll get here a squared, which is x squared minus 2ab, 2 times x times negative 5, that is negative 10x, plus b squared. The b is 5 here. This is a minus b. So 5 squared, which is 25. Or the problem like this, say I want to find 3y minus 4 times 3y plus 4. So you should recognize this as a minus b times a plus b. So a minus b times a plus b, which gives you a squared. A is 3y, square of 3y is 9y squared, minus b squared, b is 4, 4 squared is 16. This one is 3y squared, 3y times 3y. Also, we should be able to do problems like, say, 3x minus 4 times, say, 3x plus 5. Now we should recognize This doesn't belong to any of these special the binomial expressions, the binomial products. So in this situation, we have to stick to the basic mean. We need to multiply the second parenthesis first each by each and every term over here. So I get 3x times this parenthesis minus 4 times 3x plus 5. And then I need to use a distributive law. 3x times 3x, I get 9x squared. 3x times 5, which I get 15x. Minus 4 times 3x, negative 12x. Negative 4 times 5, which is negative 20. If I combine like terms, I get 9x squared, 15x minus 12x, which is 3x minus 20. So this is the prerequisite that you need to know, and now we can continue to our lesson. Now let's see how we use these two, the binomial formulas, to find a square of a number like that, 23 squared, and using the numbers that are easier for us. Now for 23 I can write either 20 plus 3, which is 23, and since I know square of 20 and square of 3, and also I can, if I want, I can write 23 is equal to say 25 minus say 2, because I know 25 squared and also I know 2 squared. Now if I use this one, a plus b squared, so a squared, which is 20 squared, 400, plus 2 times a times b, 2 times 20 times 3, 2 times 20 times 3, plus b squared, which is 9. So you get a 400 plus 120 plus 9, 529. So you get a 529. What if I do this one? This way. A minus b squared. So a squared, 25 squared, minus 2 times 25 times 2, plus b squared, which is 2 squared of 4. 25 squared is 625, minus 100, plus 2 squared, which is 4. That also give me 529. Now let's do one more problem. Suppose I need 96 squared. Now 96 is close to 100, which I know. Say I can write 100 minus say 4, which is 96 squared. That gives me a squared, 100 squared, minus 2 times 8, which is 100, times b, which is 4, plus b squared, which is 4 squared. So I get 100 times 100. I get 2 zeros and 4 zeros. So I get 10,000 minus 800 plus 16. So I get 10,000 minus 800. That will give you 9,200 plus 16. So 9,216.